Hello, this is an early build of the Reverse Engineering Provenance System. On the left, I have the Binary Ninja desktop application, and on the right, I have a Chrome browser open to my local host. It's currently set on the default view. All right, let's open an arbitrary application and enable our plugin. This allows Binary Ninja to communicate with the browser and vice versa. All right, let's assume over the course of analyzing this binary that this particular call was of interest. We would traditionally annotate it with a comment. Let's right-click, which opens a context menu, which is also accessible through the Tools drop-down in the top left. We have three different operations that currently interact with the visualization on the right: change function name, making a comment, or printing the view. As I stated, let's make a comment here. And as you can see, the provenance graph is updated with that fact. Now let's continue our analysis and go to our strings view. This particular string looks interesting. Let's annotate it in our visualization with print view. This saves the state of the visualization in this state, so we can hop to or revert at any point along this graph. Now let's jump to our cross references where this particular string is being used. Go to our graph view. In this particular function, we see it collects some user input, and then based on that input, it goes through a failure path down the tree where it displays sorry, please try again, or a success path down the tree where it says congratulations, you got the hard-coded serial. Let's change the function name, call it user IO. As you can see within Binary Ninja, it's updated, as well as that fact in our visualization. Now let's test some of the branching functionality in our provenance graph. Let's make a comment here. We'll call it test. Let's assume over the course of our analysis, we later discovered we didn't actually want test in that instruction. We actually wanted it elsewhere. So we can click up here, which reverts the state of our analysis to before when we place that comment. And let's make a comment here instead. We'll say examine. As you can see, the branching functionality is at work. Okay, so let's go to our default view. As you can see, it issues the undos for all the operations that took place before it. And then we can step through each of our states of provenance. Okay, let's go back up here. Now let's show the basic functionality for the storyboard mode, which I have down here. So with a node selected, we can hit this button and it adds it to our storyboard. Here we have a little bit more information that we can include about the metadata that was captured when we collected the view, changed the comment, or the function name. We can drag or drop. We can also delete or make a comment or copy. So we have that one added. Let's go to the comment and add that. We'll go to the view. Actually want this one where it said examine. Okay, so our storyboard is set up. When I hit play, it'll start from the beginning, and with a 1-second transition, it'll iterate through each of these different states of our tree. We can also go left and right to examine them individually, and this could be used to convey our analysis or process of analysis to others on the team or external to the team. Let's go ahead and hit play. Okay, that demonstrates the basic functionality of the storyboard. Let's look at a couple other trees that have a little bit more information populated. On the left, we have a tree that we've made some hypotheses at this particular point and then revisited that particular point a few times. And this shows the X direction compression that I use in order to fit the most amount of information possible without overly cluttering the visualization. On the right, we have the Y direction or vertical compression of information. As you can see, as more nodes are added, the space between each node gets smaller and smaller. This is about the limit of the elements that we could put at this particular resolution size for the provenance graph. All right, that concludes the demonstration. Thank you.